Hello everyone, welcome to my video tutorial on Amazon non-relational databases. In this tutorial, we'll be talking about the various non-relational databases that Amazon provides. Before I start my tutorial, I'm a blogger and I write my blog at techieandtravel.com, so do check that out. And if you like my YouTube contents, do like, share, subscribe and comment. So first, let's start with the difference between relational and non-relational database. Relational database stores data in tabular format of rows and columns that comprises of tables. So relational database uses tables that are connected to each other. In this example, we see that the customer ID key is referenced in both customer table and order table. So non-relational database, on the other hand, stores data in non-tabular format and are often based on data structures like objects or documents like in JSON format. Unlike relational database, which depends on relation between the individual tables to provide the complete picture of data, a single document within the non-relational database stores wide variety of information, and they store information in different formats side by side. So type of non-relational database can be key value database, which stores data in form of key value, and here every key is unique and allows us to access the value associated with it, like in Redis, Oracle, NoSQL, etc. Non-relational database can also be a document database which stores semi-structured data documents, especially required for developers as data in application tier are mostly represented in JSON format. For example, MongoDB database. And then it can be a graph database, which, as the name suggests, is a network database that is represented by edges and nodes to store the data. And we can have in-memory database, which depends on memory for data storage, or rather than storing the data on SSD or some disk. And this minimizes the response time by eliminating the need to access disks and provide some microsecond level response time. It can be a search database which is used to search the data content. It uses indexes to categorize similar characteristics among the data. So let's start with Elasticache, which is a in-memory non-relational database. So if you want to accelerate the application performance or ease the backend database load and build low latency data stores, you can look at leveraging Elasticache. So Amazon Elasticache provides extremely low latency, which is in sub-millisecond response time. Elasticache is a fully managed in-memory data store and cache, which enables scaling to hold large datasets and replicas to meet the application demand. So you can use Elasticache for caching, which accelerates the application and database performance. Again, it's a fully managed service, so you don't have to do anything with the management like hardware provisioning or software patching, etc. All those are taken care for you. And Elasticache sits in between the request and backend sources like database, application server, etc. And it allows faster in-memory speed for retrieving the values from the backend database. So the Elasticache engine actually supports two different engines, Redis and Memcached. Both of these are popular options to choose within the in-memory database stores, and each of them offers different features. Both are distributed memory caching system, and they are used to speed up the dynamic database-driven websites by caching data and objects. So Redis supports advanced data types and operations such as strings, hashes, and application can use these more advanced data structures to support variety of use cases. For example, you can use Redis sorted sets to easily implement a game leaderboard that keeps track of all the players that are sorted by the rank. It allows persistent caching as well, and then it can run in multiple availability zone. On the other hand, Memcached is better suited for object caching such as database, and it's simple to implement and use, and it's multi-threaded. That means you can handle more operations by scaling up the compute capacity, and it scales out to hold much larger datasets. It handles most common use cases including database layer caching. For example, if you are working with another database like DynamoDB and you want to add a cache layer in between your application and database, Elasticache will help you. And it even helps in the session storage. So if you are working with web application that is doing session storage, you can utilize Elasticache with something like Redis to be able to get the quicker response on session data. Next, we'll look into DynamoDB. It's a fully managed NoSQL database service, and it's under the category of software as a service. So not only you don't have to manage the underlying infrastructure, but you don't even have to manage the database layer as well. You simply go ahead and use the database as a software. It provides both key value and document data models that are widely used in e-commerce, mobile, or any internet scale applications. With key value, as I already discussed, you have a unique key, for example, user ID and some values associated with it. And the attributes like the name, address, or employer, or different items may have different attributes, but they can be stored in the same table. It's also a document database, meaning that you can store HTML, XML, or JSON documents as items in the table and then read those attributes from those documents. It supports automated scaling based on configuration. You can have scheduled auto scaling that leads to highly available, fault tolerant, and cost effective setup. So, for instance, if you know that at certain period of time you have high usage, so you can scale as per the scheduled auto scaling setup, or you can scale automatically based on usage. And in addition, it enables extremely low latency, you can say in single digit millisecond, and virtually at any scale. DynamoDB can handle more than 10 trillion requests per day, and it can support peaks of 20 million requests per second over petabytes of data. So it maintains consistent performance no matter how big your table becomes, or no matter how many queries are issued per second. It has multi-region native support. So this helps distribute your traffic to different geographic locations that are closer to your users, as well as mitigate the effects of some regional failure. So DynamoDB stores data on SSD storage, and it replicates across 3 different availability zones. It has multiple master, meaning there is no single point of failure for your cluster, and active data is stored in multiple locations. It has built-in backup and restore, so the continuous backup don't affect the performance or availability of any running database. You can enable any point in time recovery to restore your database at any given second in the preceding 35 days. It also has features like DynamoDB Accelerator or DAX, which gives you an in-memory cache that you can use alongside the database. So with this caching, it improves your read performance by up to 10 times. So to summarize the DynamoDB non-relational database in AWS, it's a NoSQL database service that supports both key value and document data. It's highly scalable, and it's a managed service, which is a software as a service approach, and it has multi-region availability. It has automated backup and restore capability. In terms of security, it is built in with default encryption at rest security, and it is governed by IAM, which is identity and access management, to restrict the user access to only their table, as well as you can have other AWS feature as well to enhance the controls. And then it offers in-memory caching with DynamoDB Accelerator that helps to improve the read performance significantly. Next, we'll talk about Amazon Keyspaces. It is a Apache Cassandra compatible database. It has lot of same features as the DynamoDB service. It is a managed serverless service again, so you don't have to install or maintain or patch any software or server. You can choose on-demand capacity mode, which will automatically scale up or down to meet the demand, or you can select the provision capacity mode, which will help you to optimize the price when you have certain predictable load. But whether you have on-demand or provision mode, you will get single-digit millisecond response time with low latency. So it does not matter whether you have high volume of query or low query volume, you will get consistent performance. You have managed storage, and it supports continuous backup and recovery. So if you are looking to run your Cassandra workload in the cloud, Keyspace is a good choice. Next, we'll look into Amazon Document Database. Document Database is a managed service as well with MongoDB capability. It's highly available, it provides low latency, it's fault tolerant, and it has self-healing. It's a non-relational database, and it can automatically scale up or down easily. DocumentDB makes it easy to store, query, and index JSON data. This allows you to persist the data using the same document model format that is used in application code without having to perform any transformation every time you read and write the data. You can encrypt the data With keys, you generate with the Amazon KMS service, which is a key management service. Next, we have Amazon Neptune Graph Database. Let's look at this example. Suppose you vacationed in Florida recently and you like the place as a vacation destination. You may know other people who like this same place, and there might be other people who you may not know but still like the same place. So a social networking graph could look at multiple data points and relationships in determining what you or who you may want to connect based on your current network connections. So this pattern of using nodes and edges versus the tables and keys allows easier exploration of patterns than having to create some nested queries and complex joins in a relational database. So graph database are good fit for creating knowledge or identity graphs on recommendation engines or for social networking. So Amazon Neptune Graph Database is a fully managed graph database, and it enables you to query billions of relationships within seconds. And like any other managed service, you will get high availability and auto scaling, you will get instance monitoring and fault tolerance, you will get continuous backup and restore, and you will get data encryption. Neptune also supports Open Graph APIs for Gremlin and SparkQL, and you can use the existing tools and codes when migrating to Neptune. So this is it on Amazon provided non-relational databases. We covered in depth on the types of non-relational data that Amazon supports and the type of the database engines based on those unstructured data that are available for non-relational database. And we also covered the difference between relational and non-relational database. So if you want to have a brief understanding on the relational database service that Amazon provides, I have a tutorial in my YouTube channel. Do check that out as well. And if you like my contents, do like, share, subscribe, and comment on it. I'll be doing further more videos in future. Thank you.